Nice. Welcome. Thanks for showing up. You might be wondering what this talk is about. Who's here for checking links? And who's here for the Rust part? And who wrote Rust for fun? And in production? Okay, nice. Wow. Every time I give a Rust talk, the number of hands keeps growing, which is nice. Now, I also write Rust, but I want to start with this guy. Everyone knows him. Thomas Jefferson. It will be in the exam. And of course, this is the topic of the talk, right? I don't read it out to you, but it's very important. But I will highlight the most important things. Broken links. So Thomas Jefferson was ahead of his time. He also thought about broken links. And this is the topic of today. Now, what is so special about broken links? Why would you spend a weekend and 2 years to think about this topic? Because it doesn't sound too exciting, does it? Probably when you look through the offers of different talks, you might have considered to go elsewhere because it doesn't really sound fun. Maybe I can convince you that it actually is a lot of fun and it's a real problem that we have. Do you think that you can write a link checker in a weekend? Well, it depends on what you think a link checker does and the functionality that it provides. What I did was exactly that. So, Litchi, that's the logo, is a tool which fixes links. It's somehow representative that it only fixed 2 out of 3 broken links. I cannot figure out why, but the animation is broken. But I have amazing animation skills here. But before we start, who am I? I'm Matthias, I'm from Düsseldorf. I like Rust, have been writing Rust since 2015, and I am a Rust consultant in my day job, and I think about performance issues, scalability issues, and so on. And I also, as I said, do Rust for live, or like in production. But that's not why you're here. That's my cat, and this is the same thing every day. Oscar is like, entertain me, peasant. I'm here now, I want to be entertained. Now, coming back to my original question, can you write a link checker in a weekend? Because certainly it cannot be that hard. If you had to do it as sort of a job interview, then maybe this would be something you could come up with. That's Python, but works in any other language. So you just import requests, and then you have a list of URLs that you want to check, and then you iterate over the URLs, you get the response, and if the response code is not 200, then you found a broken link. That's the end of the talk. There's a lot of issues in this snippet, and probably a few things that you might forget when you think about broken links. So what I want to do is I want to enlighten you for the problems that you will face and maybe why you cannot write a link checker in a weekend. But prove me wrong and I will pray to you. Why did I write a link checker? Because I have another project. It's a huge list of static analysis tools and linters. It's called Analysis Tools, and it's the biggest list on GitHub. The problem is that with so many tools on there, it's like 700, those links keep failing all the time, and I had to fix them manually. And at some point I got sick of it, so I decided to automate myself away from this problem. Now, I used to have a YouTube channel, and so I did this live. I did some live coding, and you can still watch the video, it's online. And I really did it on the weekend. And then the problem started, because I realized it's not really easy to write a link checker. Why is it called Litchi? Because link checker, get it? But also because there was a similar tool in Go, which I wanted to use before, and it was deprecated, and that was called Lich. So I couldn't use that name anymore. Now, of course, this is a wholesome talk, so we also want to learn more about the world, and not only about Rust or link checking. And this is why, for some context, maybe some information about litchis. So lychees come from Thailand and South Asia, and they get yielded from May to July. That's harvesting time. And does anyone know what lychee means? Or lychee? No? The gift of God, or the gift of a joyful life. Depends. And they sometimes call it the alligator strawberry. So every year they go, they harvest this. This is a real video on YouTube where you can see there's a lot of harvesting going on. So I really like the name because you can think of it as many, many different small little things that you want to harvest or you want to check. I guess it's quite a fitting name. What does lychee do? So it has a couple ways to check links. It can check links in Markdown files, in websites. It can support HTML and any other format really, as long as there's a way to extract links from it. And yeah, pretty basic. It can output JSON, and it can give you detailed information on the links that it found and the status and so on. So you can integrate that into your build process, or you can run it from the command line. Now coming back to this slide, a lot of people still say that they can write a link checker or any tool in a weekend if they need to. One famous example is curl, because a lot of people say they can write curl on the weekend. It has been such a meme that, Daniel Stenberg, the maintainer of curl, has a page where he lists all of the claims that people make about curl. I could rewrite curl, or I can do it in a 3-day weekend, or it's not that hard. But in reality, what they do is they use an existing library, which is curl. What they forget is that curl comes from a time when there was no way to check, I don't know, all of the formats that curl supports nowadays. And the other question that you might be asking is, well, can't you write a link checker in any language? Why does it have to be Rust? What's so special about Rust? Well, there's a lot of reasons to use Rust, of course, but there's a few specific reasons for this project to be in Rust. So first off, Rust has native performance. It's as fast as C. But Rust also has fearless concurrency, so you can check 1,000, 1,000,000 links concurrently if you want to, as long as your network card is happy with it. It also has zero-cost abstractions. The HTML parser that we use does not allocate memory. It just reads the file, and then it extracts the link, and then the links get checked, and you never allocate any memory for it, because why should you? It's just a pointer into memory. So that makes memory usage very, very lean. And it also has a minimal runtime. What you need is something that can execute libc code, and you can run it anywhere. Lychee runs on OpenBSD, on FreeBSD. People use it in Docker containers and outside, and everywhere in between. And there's packages for that, by the way. It's also cross-platform and interoperable. So Lychee is not only a binary, it's also a library. And there are Python bindings, which are very rudimentary, but technically you could include the link checking process in any other language or any other of your applications, so you don't have to write all of the logic for checking links. And it also is a self-contained binary. That means I can copy it from my local disk to a server, and then it runs there, and it's just very minimal. But I guess one of the most important reasons is the robust network operating system, because Tokyo and Servo are best in class when it comes to networking. What is Tokyo? It's a runtime for futures. A future is like a promise in JavaScript, something that you say will be executed in the future and there will be a result. So that's where future comes from. And Tokyo is a runtime which can run many, many of these futures or tasks or promises, however you want to call it, concurrently. And similarly, there's Servo, which is the browser engine from Firefox, the new Rust one. And we use that for parsing HTML. And Google also happens to build a Markdown parser, and we also use that as well. So the ecosystem is really quite nice. But before we start, what is a broken link? Now, I guess first we have to establish what is a link. Is that a link? Yeah, that's a link. What about this one? Sure, www is just a subdomain. It's just one of many. Actually, it's just a convention that we use www. You don't need it. What about this? Is it a valid link? What's the schema? HTTP? HTTPS? What does curl do when you say curl example.com? HTTP. So they take a guess. But it could also be a HTTPS. It could also be FTP, for all we know. But it can be a valid link. Can be. What about this? This is not a valid link because there's no schema and there's no way to say, well, is it HTTPS or not? So curl doesn't accept it, for example. But what about that? Yeah, that is a valid link. And why? Exactly. If you have a website and it contains a link like this, then it tells the browser to use the schema that it used to load the website itself. So if you go to https twitter.com and you have / twitter.com, it's HTTPS. Same for HTTP. So this is valid again. What about that? Yes. I guess we all see it as a link. This is not a link. It's just a string. Or is it? Well, if you have it in your etc hosts, then this could be a valid link for you, if it points to a valid IP. But of course, that's cheating because not everyone has an etc host with that entry. Maybe you have localhost though. Or you can have a domain like that. That's a valid link. So if you go to AI, you will be greeted with this website. And that's a TLD website. So there's the TLD owner of that domain, and he decided that he can host /AI, and this is what it does. So if it doesn't work in your browser, you have to add a / to the end, because not even Firefox believes this is a valid link. But it is. What about this? Can a domain be an emoji? Can it contain emojis? No. But the browser is smart enough to translate that into Punycode. And Punycode is a string format which represents these emojis. So it's still resolvable from your browser, but it depends on the context whether you accept this or not. This points to a valid website, though, in your browser. What would it point to? Who would use that for marketing? Love beer. Exactly. Budweiser. It's just brilliant marketing. How many people know that? Maybe 5? So you can see, you can do a lot with links. But certainly this is not a valid link, is it? That's not even emojis, that's not even ASCII, that's Unicode. That means Arabic. And again, this is a valid link, or used to be, at least, a while ago, because this points to the Arabic TLD. And there is a list with TLD with A records. And you can see there's quite a few TLDs which just execute as a browser website. Now, links can be extremely long and extremely complicated. This is a valid link. If you want to know what the components are, there's an entire blog post about it. It's in the sources, but it starts with a scheme and then a schema and then a password and then a non-QDN host name and an empty port and an empty path and so on and so on. So imagine you want to parse that with your little link checker. This is just email. I don't know. Does it feel like the audio is sometimes gone and it's on? But because sometimes I feel like there's no sound in the speakers, but might be. Oh yeah. But let's talk about emails. Now we have links, which are URLs to websites, but we also have email links. This is a valid email link, right? What about this one? Mail at example? Well, it turns out if you are the owner of the TLD and you decide to add an MX record to your domain, then this is valid. So there could be a domain like me@google without .com, for example. Okay, I don't want to bore you with all the different variants for email links, but look at the list. It's long. There's many, many edge cases. You can have space between quotes. You can have quoted double dots. You can have exclamation marks in your email. And a lot of people know that. But the point is, not all of these addresses get accepted by your host or by the email client. Technically, though, these are valid links. But a link always has an @ sign, and this is how you can detect it, no? Are there websites with ads? Well, of course there are. Of course, Medium decided to add an ad. And now you are in a miserable place already because this could also be an email address for all we know. It has an ad. So your little regex parser won't help you anymore. Links are complicated, and links are made for humans and not for machines. And sometimes links can mislead you. What could happen is that a friend of you who's also an engineer sends you a link, and you click on it because you want to download the latest Kubernetes version, for example. And one of these links is malware, and the other one is completely fine. The what? You have the eyes of an eagle. Okay, incredible. I will never send you malware. Turns out that this is a vulnerability that is possible because Google registered the zip TLD. You can get a .zip domain. Now, as an engineer, you know why this is a bad idea. I can send a lot of zip files to my friends, and I'm pretty sure a lot of people wouldn't catch that, not even engineers. Now, the difference is that one slash is normal, and one slash is like a Greek Unicode sign, which just happens to look like a slash. But it looks almost similar. So links can be dangerous, and I guess you see that there's complexity in even detecting links. But what about broken? That's easy. Now, once we find a link, we can certainly tell you if it's broken or not, no? Well, brokenness is yet another issue. Because it's not enough to check if your link returns a 404. That's sometimes when you talk to a layman, you say, oh yeah, I detect broken links, and they say, well, yeah, it's just a 404. Actually, this conversation never happened now that I think about it because they don't really care, but even engineers know that a 404 is not enough to check if a link is broken or not. Now, you might be smarter than that and say, okay, if I cannot just say it's a 404 or not, how would I check if a link is broken? Well, you just say everything that is not a 200 is invalid. Well, not every non-200 link is broken. There are links that just don't have any content. So there's the 203, there's the 206. Those are all very valid links, and they are used in APIs. That doesn't mean they are broken. You're like, well, that's easy. Then I just say everything that is not in the 2xx range. Well, also not really enough, I guess. Because there might be links outside of the 2xx range, which are maybe completely fine. For example, a 304 or something, like a redirect. Well, then you say, well, okay, if you have the 2 range and the 3 range and maybe the 1 range is fine, we know that errors or broken links are somewhere in the above 400 range. And then I say, what about server issues and client issues. How do you differentiate between those? And they say, well, everything that is between this range is certainly fine. Well, I guess there's also a temporal component to it. Because if I check now, the link might be down, but if I check in 1 second, the link is up again. So maybe I want to have retries. Maybe I want to say, retry that a couple times. Maybe I sent too many requests. So you can see that this problem, just detecting if a link is broken, is another can of worms in and of itself. And we're not even talking about the weird things companies do out there. Megacorps. For example, let's say you are at LinkedIn and you don't want people to crawl your pages. What would be a sensible status code to return to your user that's trying to check a link? Well, LinkedIn said reasonable, you would say 999. Of course. So LinkedIn returns you a 999 whenever you try to crawl them, and people will report that. They will say, oh yeah, I tried to check a LinkedIn page and it returned a 999, and suddenly this link is valid or not, I can't really tell. Or what about YouTube? What would YouTube say? Say you have the video to this talk and you want to watch it on YouTube, but suddenly the video is gone. What does YouTube return? Well, YouTube said, LinkedIn, hold my beer. I can do it better than you. Because what they do is they send you to 100 and then they say video not found in the body. That doesn't help. So the difference between this YouTube link and this YouTube link is just a little Q at the end. But the return code is still the same. How can you check that? Well, first off, you cannot check LinkedIn. There's nothing you can do about it except that if it's a LinkedIn page, it returns a 999. But for YouTube, there's a little workaround. Does anyone know? What YouTube does is they return a 404 when a video is down on the thumbnail. So if a video gets removed, the thumbnail returns a 404. So we use that as a workaround. We check the thumbnail and not the video. But then we got X. And we got Elon Musk. And X is strange because they have the most simple web service on the planet. You could serve Twitter or X on your DNS as text records. But what they decided was that you cannot crawl Twitter. So as of a couple years ago, Twitter cut off the ability to read a tweet by fetching its URL with a normal HTTP GET. You need JavaScript for that, and you need to be authenticated. That sucks. Imagine you have the biggest text platform in the world, but no one can read your text without JavaScript. Fortunately, there's Nitter. If you replace twitter.com with nitter.net, then you get this without a login and without tracking, which is really nice. And the problem with Nitter is it's kind of broken. So sometimes it's fragile. You want to check it, but you overload it because we check a lot of links. And Nitter is like, oh my God, you're crawling us or DDoSing us. And that's why I lay awake at night trying to think of better ways to check Twitter links. But recently, this is of no value because Twitter decided that they will require accounts to view for everything. Like tweets, accounts, anything, you need an account. And that's why we can do nothing but close Twitter, checking, because even Nitter is broken by now. I don't know if they... Yeah. Yeah, but I don't want to get an issue when someone says, oh yeah, Twitter is broken and then it's in fact Nitter. Yeah, it's a... Yeah. I still like Nitter. There's nothing wrong with that, but it's sometimes strange what sort of issues you run into, especially for links that should never be broken. Does anyone know a link that is kind of very important to always work and it's for the public good? We pay tax money for it. It's that! DOI links. My nemesis. DOI links are a special way to say this link will never break and it will be immutable, and you can put that into your documentation, but also into research papers, and yeah, a lot of researchers use that. And one day someone called me and said he's a researcher, he found broken links, these are DOI links, and my tool is to blame. And I explained to him, well, in fact, actually the website is broken, and I don't want anything to do with it, but he can certainly try to do it himself, which is exactly what he did. So he's going through every single DOI host and tells them that their website is broken. And he always starts with this message, your DOI infrastructure is broken, in capital letters. And he goes through the list and he's tireless. He goes through every single provider and sends the same email, and he goes through all the discussions, and he has me in CC, so it's crazy. But yeah, he's fighting the good fight. Awesome. I guess that was your weekend, because if you try to implement all of that, have fun. But let's say we're done. We fixed all of the broken links that we found so far, and we established what broken links are. Then we can finally move on with our lives. Or so I thought, because there are a lot of edge cases. Now, what about parsing for a start? How does a browser parse your website? Maybe you all wrote a website, and maybe some of you wrote a website by hand, and maybe you made a typo. So for example, your first website could look something like this, but you made a typo and you forgot the angular bracket at the end, and you wrote this. And you opened the website, and the browser was completely fine with it. That's a marvel, because they understood what you wanted to do, and they would still show you the link. That's beautiful. What about this? You have an A beginning tag and a div closing tag. And you can see where this is going, because parsing HTML in and of itself is extremely difficult. And if you want to do that yourself, have fun. That's why there's Servo, which is a HTML parser written in Rust, which might or might not get used by Firefox at some point. And they handle all of these issues for us. So what we get is an AST of the HTML page. But that's not enough, because not even Servo can handle all of the links. For example, just 2 days ago, someone reported that this was found as a valid link inside of his Markdown file. It's not HTML, but it's Markdown, a separate parser that we support. And you will keep chasing those rabbits for the entirety of your life. That's me, by the way, reading this issue in the middle of the night. That's life, I guess. Let's say you have the ideal way to parse HTML in Markdown, and you can extract links, and you know what broken links are, and then sometimes they work and sometimes they don't. How can that happen? Well, if you send GitHub too many requests, then GitHub will finally close down and say, no, I cannot handle that anymore, please wait a little bit. If you're a good citizen of the web, then you just wait a couple seconds and you're done. But if you want to check 1 million links concurrently, you cannot do that. You cannot wait for any arbitrary amount of time, because you want to check as many links as possible in the shortest time. Now, what you should do, and what is the proper way to do it, is to parse the retry headers. Because GitHub tells you how long to wait, and GitHub tells you when you're unblocked and how many requests you can make, and so on. Turns out there's no one who wrote a library for parsing rate limit headers. And why is that? This is a rate limiting header pack or something. 3 headers, super simple format. You can do 100 links, you have 50 remaining, and the reset will be in 600 seconds. That is the proposed standard by the IETF. Nice. That's all we need. Except that every provider has a different format. So Reddit said, no, let's go with X minus rate limit, because the IETF standard wasn't available when they started. And they used the same format, but just the prefix X minus. And GitHub said, no, let's do it lowercase, And the rate limit will be the Unix timestamp when it will reset. Or GitLab said, yeah, well, let's set another header observed for some reason. And let's not use the prefix, but also the Unix time. GitLab was onto something. GitLab X is like, yeah, let's do all of that lowercase and add the X. So it's also case dependent. Vimeo said, no, let's use this date format. And Akamai was like, nah, let's use a different date format. And all of these dates formats you somehow have to handle. And that's why I wrote another Rust grade to handle all of these cases. Now, if you implement such a standard, you definitely want to be sure that you can handle all the cases. So you read the documentation, of course. You go through the IETF documentation. Oh, well, okay. So, yeah, IETF documentation as of today is offline. Maybe I need to update the link, or they should. GitHub and rate limiting is my arch nemesis. Because every day, a lot of links get checked, and yeah, this is what you need to do. Now, this is only for websites that behave like normal, civilized web citizens. But what about all the other websites that are overwhelmed with your requests, but don't send you any rate-limiting headers? Like literally any website without an API. Well, then you go down the route of control theory. And there's an algorithm, for example, on how to do that. It's the token bucket approach. The algorithm is pretty simple. You have 6 tokens in the bucket. Every time you check a link for one specific host, you take 1 token out. And tokens get refilled at a max rate. And you have a capacity n, which is the max number of requests you can make. Now, with this structure, you can check any website. But you want to keep track of every single website that you check. So you have to have a hash map, which should not be locking, to be able to get a token from the bucket, which is the correct one for your host. You can see that these things get complicated once you start looking into it. But that's just the start, because Cloudflare doesn't even let you go through the website anymore. In fact, nowadays, bot detection is so bad that you need a way to fake a browser with browser fingerprinting and send all sorts of user agents, but also SSL headers and so on, so that Cloudflare thinks you're a valid user. And there's actually a test on how to do that in Litchi. Someone wrote a crate for that. Yeah. For example, someone also modified curl to impersonate Firefox for this reason. And then there's this whole other can of worms, JavaScript. The entire world runs with JavaScript nowadays. There's JavaScript everywhere. For an example, let's disable JavaScript and open the most popular websites. Let's start with Google. Pretty reasonable. They give you results. Very nice. What about Google Maps? Google Maps says, when you have eliminated the JavaScript, whatever remains must be an empty page. Almost ironic. I imagine from the biggest website in the world, you get this information, JavaScript, and then you get nothing but an empty page. That's just wrong. Well, let's not even talk about Twitter. It's kind of broken. Bing, that's everything it does. So you can ask it anything, but it's not going to reply. But you can go worse than that. Facebook or Meta. Well, honestly, that's the most streamlined feed that I ever had. So I'm not complaining. This is better than the usual website that they serve me. We went to a place where we started enhancing HTML because it was slow, to making everything in JS, and making it so slow that we have to pre-render HTML. And then we pre-render all HTML, so that becomes too slow. So we render some pages on request. And then finally, we render HTML on request. We went full circle here. It turns out that you can have a headless Chrome browser, and run it next to Litchi, but you don't want to do that. Not everyone wants to bundle Chrome with a CLI tool. There's an experiment to run this inside of WebAssembly with Dino. So you can render the DOM with something like GSDOM, and you can bundle that as a WebAssembly plugin. But this is the beginning. Another thing is recursion. Say you want to load the sitemap XML, or you want to maybe respect the robots TXT. Yeah, a website can have a lot of links. When do you stop? Do you just keep on going? Do you check all of the links on one website? Do you go across websites? If you don't want to do that, you need a crawl depth and you need a recursion limit. And there's more edge cases, many, many more edge cases. What if the server never responds? Will you ever stop checking? What if the response never stops? What if the server sends no Unicode? What if you read a terabyte file? What if you read a terabyte line? Now, can that fit in memory? No. So you need to parse that as you go, and you cannot allocate. Or you have fixed allocation. Yes? We support both. You can set whatever you want. You can use a GET request. So the thing was, if you have a head request, you wouldn't run into the terabyte thing. This is correct. But you have to remember that we also check Markdown. So Markdown could also be, we check local files as well. And those could be big files. And we realized that some servers even return the full body, even if you send a head request. So it's not going to help you. Let's look at the famous complexity iceberg. One of my favorite memes. You start at the top. You check HTTP status codes. You optimize for performance. You check timeouts, redirects. All of a sudden, you're in the deep sea. Certificates, JavaScript, rate limiting, recursion, LinkedIn, robots text, relative links, and you go down, single-page applications. People run it behind proxies, 200 but no content, browser fingerprinting. Yeah, cookies, anchor tags. It never ends. You end up writing a browser. And this is how I feel. One last thing I want to implement, and I'm done. Now you might be wondering, how does the architecture behind something like this look like? This is the CLI tool. We start at the top. We collect all the links. We extract them from the documents. Either the file is HTML or Markdown or plain text, in which case we use Linkify. And for HTML, we support two browsers. One is HTML5 Ever, which is the one from Servo, and HTML5 Gun, which is a newer one, which is like state-based and a bit faster. And for Markdown, we use the Google one. And for Linkify, we use a regex parser as a fallback, but it's actually a kind of a state machine. And for all the pages that we read, we send fragments to the fragment cache. Fragments are like anchor tags. For example, here, as a quick example, you have these IDs, and you can refer to these IDs inside of pages, and not many link checkers do that, but Litchi supports it as of now. And then on the bottom, this is the checking queue. So we start our client, we do remapping, so you can remap one to the other. For example, you have mywebsite.com, but you are a developer, so you want to check the local version. So you say everything as mywebsite.com, rewrite to localhost 300. You can do that. And then we apply quirks, which are the YouTube checks and the Twitter checks and whatever. And then we do the actual check. And we have GitHub support, so we go across the rate limiting with API support. You can have a GitHub token and be much faster. And all of that gets retried sometimes with an exponential retry. Okay, is it fast? Because kind of that's what we want to achieve, no? So I started comparing tools. And what I did was I used a very simple example. I used just a couple links, 100, 1,000 links. And I just checked how fast they are. And I wanted to see how Litchi compares. So these are different tools. This is Litchi. And sometimes you might see that there's zeros. That's because the tools never finish. You can wait forever, but it's impossible. And we try the top 10 websites, the top 50, 100, 500, and 1,500. For Litchi, that's literally nothing. But for the other tools, this is where it ends. And it all depends on your network card, so you can go much faster. This one is Lich, which was the old one, which is also reasonably fast, written in Go. And I guess if you want faster performance, you want a very fast network card, because this is what the bottleneck is right now. So I would say yes, it's reasonably fast. And this is also why a lot of repositories use it. These are some of the users. MariaDB uses it for their documentation. Google uses it for some of their internal documentation. AWS checks OpenSearch. Azure checks their documentation. HashiCorp as well. And yeah, I like it. There's also OWASP, which is close to my heart. Something for linters and static site generators. Yeah, static analysis tools. Yeah, so a lot of pipelines. And I counted recently, so we check around 2 million links per week. And whenever we make a mistake, and by we I mean me and the contributors nowadays, they will tell us. I want to maybe end the talk or have a final conversation about critical infrastructure. Because this is all fun, but in reality, there's a lot of people like me that build tools that a lot of companies depend on, and they do that in their free time. And you probably know this XKCD meme. Let's say this is your company, your cloud infrastructure, and everything depends on this one person in Nebraska who has been thanklessly maintaining something since 2003. Now, is Litchi critical infrastructure? I don't think so. But I would say the web is critical infrastructure, and you need tools to make sure that the web continues to work. Because maybe in 20, 30 years, all of our information will be gone. And maybe this is a bold claim, because how many links really fail over time? Is it really a problem that we have? Who of you remembers this website? You're officially old. This was a website where you could buy a pixel for $1. And that's why it was called the $1 million homepage, because there were 1 million pixels. Now, I wondered how many of these websites are still up. It's been a few years, I guess. When was that? Maybe 10, 15 years ago? Make a guess for yourself how many of these websites are still up. They paid money for it, so they have an interest that you can reach them. Well, it turns out surprisingly many. All the green stuff is reachable. All the blue stuff are redirects. All the orange stuff is broken. And I was happy when I saw that. I was not expecting that. 25% broken links? That's nothing. At some point I had an identity crisis. Maybe I waste my time? Is it really necessary? Well, and then I started to check some of the green ones. And this is what happens. Well, those links are technically available, but the content is just placeholders, parked domains, nasty, scammy stuff. You probably don't find the information that was there before. And there's also no more stickyrice.com, which is really unfortunate. I really wanted to check out their offer. That's just the public ones, commercial ones, but what about the public domain ones? Turns out that 50% of all cited links in the Supreme Court opinions are no longer available. And 70% of the cited links in academic legal journals suffer from link rot. That means it's a huge problem. Think about Wikipedia. Wikipedia says 50% of all links break within 2 years. That's not a long half-time. And link rot is a massive problem. Now, what can you do? You can look at archive.org, because obviously they archive your page. And they do a great service. I donate every year, and I think without them, a lot of information that I refer to would be lost. Now, archive.org has a mission statement, and they explain why they do it. And the first link they mention is the Library of Alexandria. And I thought that's interesting. What do they say about the Library of Alexandria? Well, turns out not even archive.org can archive all the links. So if you click on the first link, it's broken. And then there's perma.cc. That's an initiative from Harvard. And they allow you to proxy links and archive them, snapshot them for any research institution. And well, that's amazing. You can be a host, and then you can say, I want to support my library, and then I will create snapshots, and all of the code is open source. So I checked out their repository, and that's the latest issue. The link to library partners on the website is dead. Now, this is one side on how to tackle the problem. Archive.org is not commercial. PermaCC maybe is, but they are actually open source, but you still need to be in academia. But what about open source? What about the people like me who do that in their free time? Well, we do it in our free time because companies don't pay. Remember the list of users? Well, it turns out none of them sponsor me. And this is pretty sad, I would say. I guess if you were responsible for all of those links in all of these different companies, that would be your full-time job. And you would earn a decent salary. But since I'm not employed with them, all they give me is maybe a star, or they create an issue, and that's the end of the story. Now, you can be bitter about it and say, well, they should support us more, and it's so unfair, but in reality, I did that on my free time. No one forced me to do it. Well, officially. But yeah, a lot of companies don't really support open source. Now, what do you do if you're a private person, an individual? Well, maybe you think about ways so that they can support you, or maybe ways so that other people can support your work. Now, what I thought about was, what is the next step behind a link checker? You probably want a GitHub action, which already exists, and the GitHub action would send you issues when the link is broken. And what would be the step beyond that? Well, maybe you don't want the GitHub action, you just care about the broken links. So what I built for myself is a dashboard where I can see the broken links of all my projects. So you can run Litchi as a server, and then you can curl it with a link, and it will send that to my dashboard, and then show me over time how many of the links are broken. Which means, at least for my projects, I can look into them and fix the broken links from time to time. Now, this is not open source yet, but I will definitely open source it. It's built with Rust again on the back end. It's built with Axum, which is a web framework in Rust, and with HTMX. So there's very little JavaScript. It's literally just chart.js templates, but rendered with HTMX and loaded server-side. And I think if you want to try it, then maybe you want to follow the GitHub repository, and maybe you can set it up for yourself, or maybe talk about this problem in your company and think about whether you want to support such an endeavor. Now, fortunately, I have to say, I'm not doing this alone. And one thing I'm extremely proud about is the fact that there was a research project by 2 students from Switzerland and a professor from Stuttgart. And what they did was they wrote a bachelor thesis about link management and archive navigation. And those 2 people became contributors. They added archive.org support, so you can say litchi ---- fix, and you get archived links. You can add them, which is really nice. And I hope that they will continue their work. I thought, how could I end this talk? And I thought maybe we can do a quick demo, maybe on the command line, if the demo gods are helping me. Ah. There we go. Alacrity. Yeah. So let's say I want to check my website. So I say, I don't know how to zoom actually. Oh, yeah. So I say litchi handler.dev. Sorry. And it found 33 links, and all of them are fine. Or I have the entire Sentry documentation here checked out. And Sentry also uses Litchi to check their documentation. And one thing that you can do, which is nice in Litchi, is to say, give me all the links from all of these documents. So you can say Litchi dump and WCL. So there's 87,000 links inside of this document. So if you try to print all of them, then this is a benchmark for your terminal. How fast can the terminal print links? It's not really limited by that. Yeah, and if you want to check them, of course, you can also say Litchi dot, and maybe we can give it a verbose option, so you can see it starts checking links now, and there's a cache for those links, of course, so every website will be checked only once, and that will go on for a while, and this is limited by my network card, but there's very little CPU usage right now. Actually, at home, I checked links with 25 megabytes per second. Right now, I only have 2.5 megabytes per second because I query a single host. There was a funny story once. I wanted some real estate agent to help me, and I was looking for one, and I wanted a conversation starter, so I checked their website, and then I realized that my tool was broken because I only got 500s, and then I checked their website and it was down. Because I DOS the service, and sometimes that can happen, so pay attention. It's actually a double-edged sword. Fortunately, GitHub handles all of the nitty-gritty stuff, so I don't really care if the servers scream in the cloud. Yeah, the web is weird, simple things are hard, but small things grow into big things, and you should use Litchi. And with that, thank you very much. This guy with the microphone.
Yes. Hello? I have one example which you can check.
Go for it.
doc.coreboot.org.
What?
doc.coreboot.org.
Like that? There you go. You have a little broken link there.
Awesome. Cool.
We have too many requests on GitHub already. So we get blocked by the GitHub rate limiting because we checked all of the Sentry links before. But you did a great job.
Awesome. Thank you.
We can even see how many links you have here. Yeah.
GitHub for everyone on the same Wi-Fi.
Can I tweet that?
Do you support IPFS links?
I do not support IPFS links, but since I know that you're a great Rust developer, I'm happy for contributions. No more questions? So I guess that's it. Thank you very much.
Thank you.